Hi, today we're going to talk about thermoregulation. So why do we need thermoregulation? Well, humans are classed as homeotherms. We are warm-blooded mammals and we maintain our body temperature, the core of our body, at 37 degrees. Okay. Now there's a number of reasons for this. One is that we have to maintain our metabolic rate in order for everything to function normally. And with a 10-degree difference, our metabolic rate will change 2 to 3-fold. That's not really good for physiology. Everything likes to be in homeostasis, and so we keep our temperature as constant as possible. Thermoregulation also allows activity and flexibility. We are motile creatures, we like to move around, sometimes we need to run, sometimes we need to do energetic things, and the temperature of our body allows us to do this. It also gives us flexibility because if we can maintain our temperature, then we can go into colder environments, and this is one way that humans have been able to colonize virtually all areas of the earth. Our metabolism creates heat, and our metabolism can vary up to 20-fold, and so in order to maintain our body at a constant temperature, we have to be aware of not overheating it. So we have to have mechanisms that bring our temperature down. And our environmental varies, comes to the flexibility part. Sometimes it's cold, you need to warm your body up, and other times it's too hot outside and you have to find ways to cool it down in order to keep this 37-degree temperature constant. And most importantly is that below 15 degrees C or above 44, tissue damage can start to happen. And so in order to avoid this, we keep our body at normal temperatures, which is 37 degrees C. So this is our thermoregulatory system and how we sense and then adapt the environment. So let's sort of start over here, the external environment. Maybe it's cold or hot. Cold, you end up with heat loss, or perhaps you're being very energetic, you're creating heat. This all then comes and changes your body temperature. The thermoreceptors in the skin, in the CNS, they sense these changes and send them down afferent pathways to the CNS. And then the CNS will have a response, and if you're cold, you will produce heat, and if you're hot, you will facilitate heat loss patterns. And this is the general overview of how you then regulate your heat to maintain a constant temperature. So when you talk about heat and thermoregulation, you have to talk about heat exchange. And always remember that heat travels downhill. It will go from a warm place to a cold place. Such is entropy. And this happens going basically when it's hot, you have fast molecular motion, to cold areas where it's slower molecular motion. And the way in physiology, in physics, that heat travels is through these next 4 principles. So the methods of heat transfer: conduction. So conduction is basically the molecular transfer of heat to one molecule or another in the same state, solid to solid, liquid to liquid. Okay, this happens mainly through tissues such as adipose tissue that don't have very good blood flow, and that's conduction. Convection then is the traveling of a fluid over a hot surface. So convection could be wind passing over your skin. Convection is also blood flow passing through or over muscles. And this can be a very rapid form of heat transfer. And then we have radiation. This is generally infrared electromagnetic radiation. And from heat from the sun into the body or out, your body will radiate heat as well. And then lastly we come to evaporation, and this is essentially the skin water on the skin evaporating and taking heat with it as the liquid turns into a gas, requires energy, and it'll take heat and it makes you feel cold. Every time you step out of a cold shower, you have this large amount of evaporation, it cools your body down, you feel cold, you reach for the towel. That is evaporation. Evaporation is always losing heat. Okay, the others, heat can go in both directions. They can leave your body or come into your body. Now remember, for convection in particularly, that the thermal coefficient of air is like 20 times lower than that of fluid. So if you stand in a cold breeze, that's one thing, but it won't take away as much heat as if you're standing in a cold river. I said, so important heat transfer points to remember: conduction, convection, radiation and evaporation are all involved in heat exchange between the body surface and the environment. So it can be evaporating if you're sweating a lot, or convection as in the cold wind or in a cold water, conduction if you lean on a hot surface or if you lean on a cold surface, and then radiation, you radiate heat out, but also it can bring heat in. Only conduction and convection are involved in heat exchange within the body. So you have this forced convection of blood flow, and you also have then just the conduction of heat through adipose tissue and through the skin and poorly perfused areas. Conduction, convection and radiation can either lead to the body losing heat to the environment or gaining heat. I've already said that once, but remember, heat always flows from higher temperature to lower temperature. So if it's hotter outside, heat is going to come into the body. If your body is hot to the environment, it's going to leave. And then finally, evaporation always causes the body to lose heat to the environment. If there's evaporation going on, then heat is leaving your body. To maintain a constant core temperature, it is required that heat production and heat loss be equal. So the amount of heat you're making is the same amount is leaving, and if you're gaining heat, in order to maintain a constant temperature, you need to find some way of losing that heat.